All right, today we'll be kicking off section 4.4. Okay, we'll just mainly be focusing on this first learning target. I can evaluate trig functions of any angle. We actually did any angle in section 4.2, where we're using the XYR definitions. 4.3 went back to acute angles, right? A 30 degree angle, 60 degree angle, 45. But now we're going to go back to any angle, okay? And some different approaches and different types of problems. Okay, so here's our XYR definitions again, which hopefully I know you have memorized heading into the first quiz because you guys did a nice job. So we got to remember those again. Okay, remember sine is y over r, cosecant is its reciprocal, and you just flip it over. Okay. All right, so they're going to call r. So here's an example of an angle theta, and then they said, okay, here's a point on the terminal side, x, y, and then we call r the radius if this is like some big circle, right? We can also refer to r as the hypotenuse. Feel free to write this in there if you want to. R can be considered the radius, which is what they're referring to it as. That's why they call it r, or the hypotenuse of a right triangle. Sometimes you're probably going to want to create a little right triangle to find the unknown side. Okay, so just get used to that. R is radius or hypotenuse if we choose to create a right triangle. Okay, R isn't always 1 either. In 4.2, R was usually always 1 because we were dealing with the unit circle. Well, that's going to be changed up a little bit in this section. Okay? Okay. Let's take a look at the directions on the first one. Okay, so the point on the terminal side of an angle in standard position. So they're giving us that. They're giving us some x, y. Find the exact values of the 6 trig functions of the angle. Okay, why don't you write this in here? For this particular problem, we are given the x and the y value, right? They give us the coordinate. R is missing, so we want to find R to begin. And once we have R, it'll be pretty easy to apply our definitions. Okay, they give us a way to find R up here. It's the square root of x squared plus y squared because those are the legs. Leg squared plus leg squared, and then you take the square root. It's basically just the Pythagorean theorem, right? So here's what we can do to get this going, to get, give you kind of a visual aid. I think you guys appreciate that. You don't necessarily have to do this every time, but early on, I definitely recommend it. Okay, so if this point is on the terminal side of an angle in standard position, let's get that going. An angle in standard position. Well, in section 4.1, we learned that that meant the initial side is here, right? Positive x-axis. And the terminal side contains that point. Well, negative 3, 4 means it's 3 to the left and then 4 up. So that coordinate is over here. And our terminal side goes through that point. Okay, kind of missed it there, sorry. So there we go. The angle is rotating. Actually, we don't even know if it's rotating positively or negatively. It doesn't really matter, but we just know this is happening. Okay, so here's where you might just want to drop down the vertical side to create a right triangle. So you kind of see this relationship and you can get the hypotenuse. So this is a negative 3. Obviously, I went this way. I know it might seem kind of weird to label a leg of a triangle with a negative, but it's the coordinate plane, so it's appropriate to do so. So negative 3, up 4, and then what's the radius or hypotenuse? It's a 3, 4, 5 triangle. But obviously, if you didn't notice that, we just do leg squared plus the leg squared equals the hypotenuse squared, or r squared. All right, which this ends up giving me 25. And then we take the square root of both sides. So 5 is r. Okay, and that's why they're saying up here for short, if you didn't want to draw this picture, you could just take the square root of the x squared plus y squared, right? You could square root it right now. All right, so that's 5. And now that you especially have a visual aid on it, this should be pretty easy to find the exact values of the 6 trig functions. Let's start with sine. Sine of angle, I'm just going to call it theta, or you could call it t, whatever variable you want. I prefer theta. Y over r. Maybe you even want to label things above here. X, this is y, so you know this is 4 over your r value 5. So 4/5. Cosecant is simply the reciprocal. Okay, let's keep going. Cosine theta is x over r. So x is -3. So -3/5. Secant theta, -5/3. Okay. And tangent theta is y over x. So that's the 4 over the -3. Okay, so we usually put the negative out front though over fraction, so I'm not going to put it in the denominator, just put it out front. Cotangent theta is -3/4. Okay. Okay, I don't think we need to do 2 of these, but I want you to kind of work through this on your own now. Let's skip 2 and jump down to 3 because 3 has a radical in it. I want to see that spin as well. Okay, so I think it's going to be good for you to draw the terminal side that goes through this coordinate to get it going. It's going to be in a different quadrant this time. Go ahead and try number 3. All right, quick checkpoint to make sure you set this up right. So we're over 2, down 1. Terminal side goes through there. We don't know if it's rotating negatively or positively, but it doesn't matter. As long as we have x, y, and r, we're good to go. So when we end up with square root of 5. You'd never make the radius negative. You might be wondering that. The x's and y's can be, but the radius is always positive no matter what quadrant you're in, okay? All right, continue on, get the rest. All right, don't forget the advice I gave you before rationalizing sign. When it's like this, flip it over now to get your cosecant. That way it's not as messy. And then when you rationalize this, we get negative square root of 5 over 5. It's not that it's impossible, but if you didn't notice that, then for cosecant, you'd have this, and then you got to rationalize it again, which will still work, but just a time saver trick. So for cosine, secant theta is square root of 5 over 2. Okay. And cosine will be 2 square root of 5 over 5. 2/5 is reduced, and I'm done. And there's tangent and cotangent. Okay, so a lot of review going on here with our definitions. Just a little different approach that we got to get used to. A point on the terminal side is given, so find your missing side and you'll be good to go. All right, now notice there's a little bit of a rule or pattern for the signs. Every time you get out of the first quadrant, only one pair of these is positive. Sine and cosecant were positive. Everything else was negative. When we went to the fourth quadrant here, number 3, only cosine and secant were positive. Everything else was negative. Okay, there's some rules that we can count on with these signs of trig functions, and that's what we're going to get into on this next page. Okay, so this diagram summarizes that for us. When we're in the first quadrant, x is positive and y is positive. So everything, when we do x over y over r, x over r, all those definitions, everything's positive. When we rotate to the second quadrant, sine is positive and the other two functions are negative every single time. Okay, it's a rule we can count on. Obviously, the reciprocals follow suit. Okay, does that make sense? Because if we go back to number 1, you have a positive 4/5. You flip it over, of course, it's going to be positive. So its reciprocal will have the same sign. Okay. All right. So we have a way to remember this. A little acronym that you're going to want to write down. We call it a SMART Trig class. A SMART Trig class. Now, this is just a quick and easy way to remember what's positive. Not what's negative, but what's positive. So a lot of times in short, too, when we draw this and refer to this rule, I'll do it this way. I'll just put a capital A here, and I'll put a positive up here. So if all are positive in the first quadrant. S is for sine. So in the second quadrant, only sine is positive. Everything else is negative. Third quadrant, T. Tangent is the only one that's positive. Everything else is negative. And then C stands for cosine. Only cosine is positive. Everything else is negative. Okay? So a SMART Trig class. Get that phrase down and realize it just kind of rotates around this way through the quadrants for the rule. Okay? All right, so for number 4, it says let theta be an angle in standard position. Name the quadrant in which theta lies. So what they're saying is like sine of theta is negative, meaning something like this, like a sine theta equals -3/5. Right? That's a negative value. So where does that happen? So this is kind of just a process of elimination. So here's what I recommend you do. Well, you just kind of get a coordinate plane going here. And let's write our rule in here. A smart trig class. Okay. This says sine is negative, like a negative 3/5. Well, the angle can't lie then in the first quadrant because all are positive. This says sine's negative. So it can't lie here, and it can't lie in the second quadrant because sine is positive. Okay, it could be in these two, right? Because only tangent's cosine is positive and sine's negative. All right, let's move on to the next statement. Cosine is positive, greater than 0. Well, here's where cosine's positive. Cosine's negative here because only tangent's negative or positive and cosine's negative. So that's gone. So because of those two inequalities, we can assume that the angle rotates around and finishes in this quadrant. The answer is simply quadrant 4. Okay, it's take a little while to get used to. Let me give you a little heads up on 5 and 6 and let you try it. This says tangent is positive. This says cosecant is negative. So what you might want to do is write its reciprocal. That might help you for this rule. This would mean that sine is also negative. So you can do the same for these, right? Cosine's positive. All right, I'll give you a minute or two to think those through and name the quadrant. This would be the last 2 examples today. Okay, so just create a new coordinate plane is going to help you. Just start fresh. So this says tangent of an angle has a positive value. Where does that happen? It happens where all are positive, and it happens where tangent's positive right here in the third quadrant. Tangent's negative in the other two, so we can eliminate those two now based on that statement. Okay, so now I move on to the next statement. Sine is negative. Well, there's no way it can be in the first quadrant where all are positive. So it can't be here. Got to be in quadrant 3. Okay, and the last one. Cosine is positive. Okay, so like I said, just one at a time. Where's cosine positive? It's here and here, meaning it can't be in these two. Okay. Tangent is also positive. Well, remember, it says cosine's positive. That means tangent's negative and sine's negative here, right? So it's got to be in the first quadrant. Tangent, we can eliminate the fourth quadrant and say quadrant 1 now. Okay, that's it for today.